Okay, 7 testing principles as part of the foundation level of the ISTQB 2018. These from the section 1, chapter 1. This is the third part of it, so there's a lot to go, but let's focus on these 7 testing principles. Number 1 shows presence of errors, bugs, defects, and failures. Number 2, exhaustive testing is impossible. Number 3, early testing saves time and money. No brainer. Number 4, defects clustered together. Remember that. Number 5, be aware of the pesticide paradox. Keep doing on and on and on and on. Expect a different result. Number 6, the testing is context dependent. There's a lot of material around that. Context, what's in context for testing. Number 7, absence of errors is a fallacy. Let's expand each one of these. Number 1, testing show the presence of defects, not their absence. There's a quote there, I paraphrase it. I'm not going to read all of it, but testing can show that the defects are present, but cannot prove that there are no defects. So you have to remember that there's no silver bullet when it comes to testing a system. There's a lot of misconception out there, but just bear that in mind and remember these. One of the principles is defect free. There's no way, So finding a defect doesn't not mean that there were no defects in the software before it was discovered. It only means that the testing found one, and find a defect does not mean that the software is correct. It could be, but it doesn't necessarily mean that. It only means that the testing did not find that particular defect, that it's hidden somewhere there. And finding the defect doesn't mean that the software is defect free as well. So could be, but it's not. So it only means that the testing found no further defects in different contexts. Number 2, exhaustive testing. So testing, it means testing all the possible ways of testing, like all the possible scenarios, all the possible combination. It is impossible. It is impossible mainly because of time. It's not feasible to do, and it's not practical to do all the options, except in some certain particular cases, okay, as it is quoted on from the syllabus here. So rather than attempting to test exhaustively, just have the risk analysis approach. Many places I work with, they have on the organizational strategy to have the risk approach. It narrows down the time consumed for testing. There are test techniques as well, and it all comes with experience. Risk analysis determine which types of software problems are most likely to cause serious problem, and if they are not caught during the test process. So risk analysis also reviews how to prioritize test efforts by identifying which test techniques are more appropriate to uncover that particular riskiest problem with the system. Test techniques determine how to test more efficiently, depending on the system, the place, the time. These test techniques, include generating inputs and preconditions that are expected to cause a problem. So you are trying to make the system fail so you can capture what you intend to find out. And the techniques are monitor outputs for unexpected changes, and observing how the software responds when it's placed under abnormal load test. Okay, next, number 3, early test saves time and money. You're gonna hear this a lot. I always push to get early involved as possible. Not many places are open for it. You have to push for it. You have to justify that you can get involved early. Do static testing, on the documentation, on the user story, asking the question, and start to think about how am I going to test these, and ask for a talk through. And whenever you are allowed to get into meetings that people, and just hear people discussing, and start to think about and ask questions. Why this, why that, how, and that will help you find out which technique that you're going to be using, which are the risky areas as well. Normally comes at that early stage. So yeah, it helps uncover defects at the early stages, like I said, and that helps you prevent to have a bug on the system. So most people just focus on like, oh, let me create I've uncovered 10 bugs today, but not many people think about prior that, how can I prevent to have a bug on the system, and that can be awesome when you do that. Okay, number 4, defect clustering happen. If something happens in one place, it's almost certain that it will happen somewhere around it where it happened. So you typically find related bugs derived from that bug where you was found it. So always have that in mind. So while you're testing and find a defect, just ask if you understand how to read code as well, or talk with the developer and see if you can get around involved on that and expand your testing around that area. That's something to remember, and it will fall on the ISTQB as well. So defects do cluster together. So the easiest way to do this is by improving the quality of the source code, which may be the responsibility of the development team. However, the test team can also improve the ease of testing by automating as much of the testing as possible with use of tools, or by reducing the effort required to perform the testing. Okay. Next, so the pesticide paradox. I like this phrase, Basically what it means is like you keep doing the same thing over and over and over and over and expect a different result. So the definition of insanity there. So if you continually run the same tests, you won't find new bugs. And the quote is there from the ISTQB. Yeah, so if a large number of tests are executed at the same time, it's likely that they will produce many false positives. False positives are not dangerous and can be ignored, but they are inconvenient. So we are likely to ignore them or stop them using the test entirely. So it can actually, get on the way and kind of cloud your perception of what you really should be looking at. So an example of a false positive that is likely to be ignored is if a test is designed to find a certain type of defect, but occasionally produces a false positive. So if a test is designed to find a certain type of defect, but occasionally produces a false positive. So remember that, and then you remember pesticide paradox. That's part of the fundamentals of the testing principles. Okay, part of one of the 7. Number 6, context dependent. So testing is context dependent. Test is done differently in different contexts, in different systems, and different, there's different approaches. For example, I paraphrase this from the syllabus, safety critical industrial control software is tested different from an e-commerce app, obviously. So as another example, testing in an agile project is done differently than testing a sequential software development life cycle, like waterfall or V model or Y-agile. You're gonna hear that as well. Y-agile. That word doesn't exist, by the way. Well, it does exist, but not officially. So since testing is done differently in different contexts, it is helpful to understand the underlying principles of testing. That is value in knowing with all forms of testing share, what they share in common. There are benefits to understand the basics of testing. So learn the master basics. By understanding the basics, you will be in a position to apply them where they are most needed. And it comes with experience again, Number 7, absence of error is a fallacy. So software with no known error is not necessarily ready to be shipped. And what do I mean? What do I mean by that? Doesn't match the user and business expectation. And again, there's a quote in there from ISTQB. But so let's say you work on a system and then you find no bugs. Everybody's happy. Developers are happy. Testers are happy. Project managers are happy. Oh, we delivered in time. There's no bugs. Everything must be fine, right? But then you go into the UAT and then you still pass on UAT. UAT is the user acceptance. So it's when you invite users to use the system before it goes live. And once it goes live and then the user starts using and says, look, the system works, but it's not what we want. It's not what we expected. So there's this kind of error as well. So error, remember in the previous videos, talking about error, it starts with human. So, and then you need to see the root cause as well. There's another important part as well that falls into the ISTQB. And then you do the root cause analysis and find out that, okay, so that error at the beginning, the root cause, when it was delivered, even though all the development and the testing, everything were fine, but when you go live and then you realize, oh my God, it doesn't match what the user or the overall business expected. Yeah, there's two in quote questions there. What is the purpose of my testing? Or what should my test achieve? So you have to bear that in mind all the time, from the test plan at the beginning, based on this test strategy of the organization. If there's one, you have to have this in mind at all the time, okay? And that is part of the principles of testing, okay? And here, this is another step that I like to do, which is repeating myself. In most of my videos, you're gonna see that, and all the materials that I produce as well, I like to repeat in a different way and talk in a different way, because I believe that by repetition you can learn and absorb better, and you get imprinted on your subconscious mind. Here's what we just talked about in a different way. So number one, testing shows the presence of defects, not their absence. Number two, exhaustive testing, testing all the possible combinations impossible. Early testing saves time and money. Defect clustering happens. So if there's a bug in one part of the software, the chances are there are others, related bugs nearby. And number five, the pesticide paradox, continuing running the same tests won't find new bugs. I like to associate these with the definition of insanity. Keep doing the same thing over and over and over and over, expecting a different result. Number six, testing is context dependent. Testing is done differently in different contexts, different systems, different approach, different techniques altogether. Number seven, absence of error is a fallacy. Software with no error or no known errors is not necessarily ready to be shipped. You got to ask the question, does it match the user or business expectation? Now I conclude this part of the principles of testing. I hope you like this part, and I'll see you on the next video.